Okay, just to go over this one again, we did this in class together. We're taking a rectangle, length x and width y, and we set up our let statements. Let x equal the length, let y equal the width, and we want to maximize our area. So our area is going into our y1, and we're having a perimeter in which we use 100 feet. And we established our perimeter formula as 2 times x plus y, 2x plus 2y, and we factored out the 2. In this case, our perimeter is equal to 100. So we divide by 2, and we solve for y. And you substitute into this one. So in your y1, you put this in your y1, and since you're maximizing an area, you're getting a graph with a maximum. You're going to find your maximum point to be 25, 625. This is the x, the length. This is the maximum area. To find your y, plug the x back in, and you will find your y of 25. We will do the same thing again using our rectangle, length of x, width of y, and we're going to maximize our area again, but this time our perimeter is 36 meters. So again, we'll solve for y, subtract the x, and we'll substitute in. Again, you're getting a maximum because you're maximizing your area. You can tell from this that your domain, if you look for your zeros, will be between 0 and 18 if you set this equal to 0. So you can kind of get a figure for where your domain is going to be. So do your maximum, and you will find that your maximum is 981. 9 being the x value, 81 being its maximum area. So plug it back in here, and you will find that y is also 9. You have an x of 9 and a y of 9. On this one with your flow rate, this is the equation that you're going to put into your y1, and x will represent your v. Now the one thing to be careful of for this is that your y is representing a flow rate. A rate is usually given in a percent. So for instance, 30%, when we convert that to a decimal, is 0.3. So your y is very small. Once you graph this, look at your table, you will see that all your y's are less than 1. So not only do you have your x min at 0 and your y min at 0, your y max you might want to just set to be 1 and maybe scale it to 0.10s. Your x max, you can probably let it go to 50, or in this case I put 70. Find your max on this, go 3 decimals. You can see right there how small your y is. This is your x value, this is your y. This is your flow rate, and x is your speed. In this example, we are also using a rectangular pasture, but we're putting it adjacent to a river, which means you only now need to fence in 3 sides. Whether you use x, y, y, or y, x, x, you will still come out with the same answers, just a different dimension. So again, when you set this up, make sure that your diagram shows that the third side, the fourth side here, is not being used. You're only going to be using 3 sides. And we want to find the least amount of fencing. So we want to minimize your perimeter. And in this case, my perimeter is x plus 2y. So they give you what your area is, convert it to the y, and substitute it in. You notice that these numbers are large. So when you're minimizing, you're looking for your minimum point. Go to your table, look at your table. Your numbers are large. You might want to jump the table a little bit, like go to table set, do your table set, and start at 0 at first, and then maybe jump it to 500, or jump it to 1,000. You know, you'll kind of see where you're increasing and decreasing. You're going to be decreasing in the y, and then increasing. So you can start your table set as long as you see it, and jump around, maybe go 300, then 600. Keep looking for the increase and decrease. So now when you get here, you're going to do your minimum point, and your minimum is going to be 600 and 1,200. 600 is your x, plug it in here, and find your other y, and your y in this case is 300. I'm going back to number 7 because I think we missed number 7. Number 7, you found the length and width of a rectangle that has an area of 64 and a minimum perimeter. This is what's going into your y. Your y1 is our perimeter formula. Your area is here. Substitute in your y. And plug that in your y1. Again, you're looking for a minimum. And your minimum comes out to be 832. This is your x. This is your minimum perimeter. Plug this back into your formula and find your y. So you have an x of 8 and a y of 8.